Okay, a crate of mass 300 kilograms, there's my crate, rests on horizontal ground, there's my horizontal ground. The coefficient of friction mu is 0.5. A force of x newtons acts at an angle alpha above the horizontal is applied to the crate. Let's say it's applied in this direction, so it's applied like that. Find the greatest value of x for which the crate remains at rest. So we've got a force being applied this way. Well, what's stopping it move? Well, the friction, which is going the opposite direction of movement or intended movement. Let's put the forces in. Okay, well this is our force x, which is at an angle of alpha above the horizontal. Let's put the angle in. And let's put our force is big X. And we've already talked about the resistance. The intended movement is this direction, so therefore the friction acts in the opposite direction. The friction is acting to stop movement. Okay, and friction will be just enough to stop movement. Okay, so let's put F in for friction. Right, the other two forces. Well, we got the force due to gravity of mass times acceleration due to gravity, mg, 300g. So that is actually 300g. I could put 3000, I could put 300g, I'll put 300g. Well, why is it not accelerating downwards? Well, it's because the floor is solid and there's a normal reaction of the floor. So let's put that in. That force there, R, is stopping it from accelerating downwards. So there's all our forces. Well, let's talk about friction. Friction is a complicated force. Some people call it an intelligent force. Intelligent because it varies according to what it needs to be. So if x is 0, if we're applying 0 newtons here, then the friction will be 0. Okay? Because it only needs to be 0 to keep it from moving. Okay, if this is increased, then the friction will increase. Okay, now it's not going to be the same. If that's 1 Newton, the friction is not going to be 1 Newton because this is resolved. But anyway, as x is increased, F will increase, and it will keep increasing to stop it moving, and it will carry on doing so. But it will come a point where it has a maximum, okay, and when it gets to that maximum, and x is on the point of moving, any more force after that, then it will move. Okay, so on the point of moving, so x is being increased such that it's just on the point of moving or accelerating. If x is increased any more than that, it will accelerate. Okay, so it's at its maximum for the crate to still be stationary. Okay, so at this point, F is at its absolute maximum. The friction can't increase anymore. Okay, and that value of F equals mu r. Okay, mu is the coefficient of friction, and that's due to the surface in the crate. Okay, and they're telling you that it's 0.5, that's fixed. Okay, r is, well, it's due to the weight, but it's also due to x. If that was increased, then r wouldn't have to be so much. Okay, now if it wasn't on the point of moving, if x was reduced, then F wouldn't equal mu r, x would be smaller than mu r. Okay, so you can see overall F is always less than or equal to mu r. Okay, but if it's on the point of accelerating, that's equaling equilibrium, then F equals mu r. Okay, to sum up, because this is very important to understand, okay, when the the greatest value of x for when it remains at rest is when it's on the point of moving or on the point of accelerating, but it's not actually moving, it's not actually accelerating, but it's on the point. And it's when f equals mu r. Okay, now if x is increased more and it starts accelerating, f will be fixed at mu r. It can never increase, it can never be greater. So f equals mu r when it's on the point of moving, on the point of accelerating, or when it is accelerating, when it is moving. So f is going to very much come into our calculation, so we need to calculate f. F is mu r. Well, mu is 0.5, we need to calculate r. So we need to calculate r first, okay? So we're going to do that by resolving upwards. Right, resolving up. Now, it's not accelerating up, it's in equilibrium. So if we apply f equals ma, ma is going to be 0, the acceleration is 0. So instead of working out the total resultant force up and equaling it to ma, equaling it to 0, we can just say total force up equals the total forces down. So that's what we're going to do. Alright, so total forces up. Well, r is very much going up. F is at 90 degrees, so that's neither going up nor down. So that has no effect resolving up or down. It has no effect up and no effect down, so we can ignore the F. X is a positive force up. It's more going up than down, so we need to resolve that going up. Okay, and the 300G is going down. Okay, so right, total force is up. We have R. Now we got we got X, but we need to resolve it. Now, if you resolve X going down, X has a component going to the right, but it also has a component going up. The component going to the right is X cos alpha, and the component going up is X sine alpha. So we've got X sine alpha. Right, let me explain a little bit more why it's X sine alpha. Okay, just think of that hypotenuse as X. Okay, so that length is X. There's our angle alpha. Okay, so it has a, well, looking at this, it looks like the alpha is small. It's got a small component going up, so it's the size of that angle. With SOHCAHTOA trigonometry, it's just X sine alpha, the hypotenuse times sine alpha. Okay, and if we wanted to know what the horizontal component, well, it looks, according to this angle, because it's small, it's got a bigger component, horizontal component. Okay, so look, it's going to be the hypotenuse cos alpha, because it's the adjacent opposite. Right, so we got components going up. We got R plus X sine alpha equals all the forces going down, because they're equal because there's no acceleration. So the only force going down is 300G. Okay, from here we can calculate R. Okay, so I've just made R the subject. So take sine alpha is 0.28, G is 10, and then have R on the left-hand side. So R is 3000 minus 0.28x. So now we can use that for R when we resolve horizontally. Right, now we're going to resolve to the right. So notation, resolving horizontally to the right. Okay, now we've also going to the right, we've also got zero acceleration, so we're in equilibrium, so we can say the forces to the right equal the forces to the left. So R is not going right or left, it's 90 degrees, so that's not going to be part of the forces to the right. 300G is not going to the right or the left, it's 90 degrees. to movement, so it has no effect. So we've only got two forces, F and X. So we could say the resolved X, if we resolve it in this direction, is going to equal F. Okay, so let's go ahead. So if we resolve X in the horizontal direction, it's going to be X cos alpha. We talked about why it's cos alpha in the last bit, and that equals the forces to the left. It is equal because there's no acceleration. Okay, it wouldn't be equal if there was an acceleration. Equals F. But what is F? F is mu r. So let's not put F in. Let's write that as mu r. So it's mu times r. Well, what is r? Well, r is 3000 minus 0.28 x. Right, we need to write the exact value of cos alpha. Okay, well, the exact value of sine alpha is 0.28. So using sine squared x plus cos squared x equals 1, you know that cos squared alpha is 1 minus sine squared alpha. So sub sine alpha in is 0.28. So cos alpha is the square root of 1 minus 0.28 squared, which comes to 24 over 5. Okay. Okay, so I've subbed in cos alpha for 24 over 25 and mu is 0.5. Okay, so we just need to solve for x. Okay, multiplying the brackets out here, we have x times 24 over 25 equals 1500 minus 0.14x. So take the x over here. Okay, finish it off. 1.1x equals 1500. So divide by 1.1. X is 1363.6. Okay, and you can round to appropriately.